Hello, this is Business 271, Chapter 6. This is a video to help you with homework, quizzes, and studying for the exam. I will also put this up as as an extra credit video quiz. It'll be worth a few points. Okay, but this is mainly just to help you with the quizzes and studying for the exam. So here we'll start real quick. We're working with continuous distributions here, and the main one we're going to work with is a normal distribution. That is the bell-shaped curve that you typically find. We'll work this problem here. This is off of Cengage. It's a Chapter 6 assignment, and this is just to help you. Which of the following graphs accurately represent the probability density function? Now here we have a random variable is normally distributed with a mean of 50 and a standard deviation of 5. So here we have the mean of 50. This one has a mean of 50. This is not a normal distribution, so we know that's not the answer. The distribution of this is 5, but it's upside down. And this has, standard deviation is 5, and standard deviation here is 5. So of course number 1 would be our answer. That would be the correct answer. Let's select number 1 here. Oops, graph number 1. Now, what is the probability the random variable will assume a value between 45 and 55? And they want us to round this out to 4 decimals. So here, we're looking at what is the probability that a value could fall between 45 and 55. Okay. So what we're going to do is we're going to calculate z values for x equals 55 here, and the z value for x equals 45. Then we're going to look those values up in the back of the book and calculate the probability between 45 and the mean and add it to the probability between 50 and 55. And that will give us the probability that a value falls between 45 and 55 here. All right, welcome back. Here we go. We're going to do this on the legal pad here. You can see I've got this distribution drawn. That was the same distribution that we had on the problem here. I've got a mean of 50, a standard deviation of 5, and then here I've said, okay, here's x equals 45, and here's x equals 55. Now the probability that a value in this distribution could fall between 45 and 55 is equal to the area underneath the curve between 45 and 55. Okay, now we're going to calculate that using a z-statistic, or z-score. The z of any x sub I is equal to that x sub I minus mu over the standard deviation. This is for a population here. Okay, we know it's a population because we're using a probability density function. So here we can stick values in. We'll start with z when x is equal to 45. And as you can see here, we take 45, which is the x sub I, minus the mean, which is 50. And we divide that difference by the standard deviation, which is 5. So I have negative 5 over 5. That comes out to be a z of negative 1. So now we're going to go to our z tables, and we're going to find a z of negative 1. Now these are cumulative probability distributions. So this tells me if z is equal to 1, we'll see in a minute here, it tells me the value of all of the probability to the left of that number. Now we don't want the probability to the left of 45. We want the probability to the right of 45 between it and the mean. That's what we're going to calculate here. So I go down here to find a z of negative 1.00, and that is 0.157. Now, that's the area to the left over here. That's 0.1587. We want the area here. We know that from the mean all the way to the left, that's half of the probability. So I'm going to subtract 0.1587 from the 0.5, and that gives me 0.3413. So the probability between 45 and the mean, 50, is 0.3413. You can't read that. 0.3413. Now we want to find the probability to the right of the mean up to 55. So we'll calculate the z for 55. And that is equal to 55 minus 50. That's x sub I, which we said was 55, minus the mean over the standard deviation of 5. That gives us 5 over 5, or positive 1. We scroll over here and find the probability, the cumulative probability for 1.0, positive 1, and that's 0.8413. But that tells us the probability, all of it to the left of z, and we don't want all of that. We only want the probability to the left, is between 55 and the mean, 50. So we know, again, half of the probability is to the left of the mean. We want the probability between here and here. So if we take the cumulative probability of 0.8413 that we got here, subtract half of it, that's the half that falls to the left of the mean, what's left over will be the rest of the probability that we're looking for. And that comes out to be 0.8413 minus 0.5, 0.3413. And that makes sense because the z was 1 here and negative 1 here, and that had 0.3413 of the probability between it and the mean, a z of negative 1 and the mean. So it's going to be the same between 1 and the mean because this is a symmetrical distribution. So we add those two together and we're going to get 0.6426. So we can say that approximately 64.26% of the observations will fall between 45 and 55. Thank you very much, and we'll work another problem later. Thank you.